to Balachandran. I have 8 years of teaching experience. Here I am going to start a course for class 9 students based on the new cbse syllabus. This is actually a chapter 8, Journey Inside an Atom. Before also last few years also it was there, but now a little bit modified. So last 8 years I was teaching the same syllabus. So let's go through this one. So journey inside an atom. So starting we have to study about what is matter and how it is related to atom. That and all from smaller classes onwards you all are studying. So what is matter? So matter means what? Matter is any substance that has definite mass and volume, that needs a volume to occupy. That substances are known as matter. So if we divide that matter, then we get the smallest particles as atoms. So many atoms together, many atoms there means that atoms combines together, you get molecules. Then these molecules combine together, we get matter. Actually, this is the order of forming matter. So atoms there, so many atoms combine, you get molecules. Then these molecules combine, you get matter. So this is the order of formation of matter. So hope you understood that portion. So then here in this chapter we are discussing about what is inside atom. So as per old philosophy and all, means old scientists also, they didn't know that matter we can divide into small particles, so that much idea was not there. But later they found out different small particles they found inside atom. So from that they identified that okay, inside atom also there is something there, certain particles are there. Okay, starting they thought matter we can't divide, but later they found out that matter we can divide into smaller particles called atoms. Then inside the atoms also there are small particles. So that particles we later, now we know that there are electrons, protons and neutrons there. So how we reached there? That is what we are discussing in this portion. So first portion, I'll start here. So that one, the first scientist who proposed that about this first subatomic particle in atom is is J.J. Thomson. So here in this picture you can see the scientist J.J. Thomson. What he proposed or how he reached his concept. We all know that J.J. Thomson found electrons there. So how he reached that concept? So he proposed the model called cathode ray tube experiment. Using his cathode ray tube experiment, he proposed the idea of negatively charged particles or electrons he proposed, or another way it is called cathode rays he proposed. So here in this picture you can see this model of this cathode ray tube. So this is just an means glass tube here. Inside certain gas is there. Then here you can see one cathode and anode there. So what do you mean by cathode? Yes, here you can see the charge, negative charge. Anode means positive charge there. So cathodes are negatively charged electrode. They are connecting to negative charge of this terminal. This is a battery. So here it is connecting to negative terminal of this battery. So here this metal piece, this metal is connecting to this negative terminal. We call it as cathode. Then this side, this is connecting to positive terminal of this battery. So here it is known as anode. Then inside this glass tube we are filling any gas, can fill any of that gas. Then he filled that time any of that gases. Then he observed that Then from his observation, he identified that certain rays or certain rays or charges are passing from this cathode to anode. So it is traveling from cathode to anode. Then he understood that the rays are consisting of negatively charged particles, because you know that what negative charges got attracted towards positive charges. So these negative charged particles later identified as electrons, named as electrons. So this was his findings about electrons or as a subatomic particle inside the atom. So this model is known as cathode ray model, cathode ray tube experiment. Okay, then next is then based on that, means he found out the electrons. Now he understood that negatively charged particles are inside the atom. So based on that, he proposed a model for atom. Nowadays itself, they understood that atom is electrically neutral. So to prove that, now he got that cathode rays or that electrons are also having negative charge. So, but as atom as a whole is neutral, so something must be there to neutralize the charge. So as based on his theory, he proposed atom like a watermelon. You can see here this red portion of the watermelon, that he considered as the positive portion of an atom. Then the seeds are he considered as the negatively charged seeds, like that he considered it. Then he considered as a whole, the amount of negative charges are always equal to the amount of positive charge in that atom. So that's why atom as a whole becomes neutral. Hope you understood, right? So this is Thomson's model of an atom. So he proposed atom like a watermelon. So then he explained that based on the red portion inside that watermelon is considered as the positive portion of an atom. Then to neutralize that much charged, negatively charged electrons also there, as in the form of seeds there. So the negative charge and positive charges got cancelled. Then atom as a whole get it as neutral. So that is the reason atoms are neutral there. So that was his explanation from his cathode ray tube experiment. Hope you understood, right? Then here you can see one more question is there, that we will just go through that question. So suppose you made up your own atom as Thomson described, using clay for the positive charge and small beads for the electrons spread through it. What will happen if the positive charge on the clay is lesser than the total negative charge of the beads? If the positive charge on the clay is lesser than the total negative charge of the beads, what will happen? So always, if atom neutral we know, so the positive charge must be always equal to that negative charge. So if here it is given negative charge of the beads is more, means yes, so the atom must show negative charge. Atom is not neutral, then the atom must be negatively charged. Okay. Then by mistake the clay itself carries a bit of negative charge. Would your model still represent the neutral atom? So by mistake the clay itself carries a bit of negative charge. If the clay also carrying a bit of negative charge, what happen? The negative charge is increasing, means the amount of negative charge is more than the positive charge. So the atom as a whole not become neutral. That becomes negative charge, negatively charged. So that is also not true. We can't say atom is as a whole it is not neutral. Okay. So that's it. So next, could an orange or a lemon, which also contains seeds inside soft pulp, be a good comparison? In what ways does it match Thomson's idea, and where does it fall short? Here the question is, he proposed atom model as like an watermelon. We can compare that with orange or lemon. Yes, like because they are also inside the fruit mostly similar to that watermelon. There's pulp is there, pulp portion is there, then seeds also there. So the pulp portion we can consider as the positive charged one, then that negatively charged portion as the electrons, we can consider them as electrons there. So if the amount of positive charge and negative charge is equal, then we can consider atom as a whole is a neutral also. Okay, so third question, why did Thomson conclude that electrons are present in all atoms? How he understood that atoms are present in all, how he conclude that electrons are present in all atoms? From the cathode ray tube experiment. From the cathode ray experiment, the tube, he understood that cathode rays are, means negatively charged rays are traveling or moving from the cathode to anode, that carries the negative charge. So from there he understood that certain negatively charged particles are also there in an atom. Okay, whichever gases he taken, he did his experiment with different types of gases. Different types of gases he taken, he changed cathode and anode, different materials or as cathode and anode, but then also there was no variation in the experiment, means experimental observation that shows the same observation. So then he identified, or then he proved that electrons are present in all atoms. Okay, this is about today. This is about today's class about atoms. Hope you understood. We'll continue in our next session. Thank you.